The fourth sample was collected by Jeanette McKinley in her fourth-floor apartment on Cedar Street and Liberty Street in New York City. This is a very interesting sample because Jeanette's apartment was just across the street from the World Trade Center plaza. And as the South Tower collapsed, she was in her apartment. And the force of the collapse and the debris blowing from it across the street broke her windows of her apartment, and the dust flowed in. We actually have photographs of the interior of Jeanette McKinley's apartment with this layer of dust everywhere. Now this is a very important sample because it was collected immediately as the tower was falling, you see. Yeah, I should mention that Jeanette McKinley, like so many others who breathed in this dust, this toxic World Trade Center dust, she has become very sick, extremely ill. And many have died from this, and this has been attributed to the toxicity of this dust, which, according to scientists, had an alkalinity equivalent to that of liquid Drano. There's also asbestos in the dust and other nasty things like mercury. So let me just talk a little bit about the toxicity of the dust, having discussed now the chain of custody for each of these samples, which is clean, and we'd be glad to testify in court about these samples and the independence of them, the fact that they were not and really could not have been seeded. I rather resent that accusation, as if I knew how to make this stuff to begin with, or would have a proclivity to seed scientific samples. No, we're behaving as scientists and proceeding in a scientific manner as we study this dust. With regard to the World Trade Center dust sample collected by Jeanette McKinley, she told me that she had a sense that this dust could be usable in an art project of hers, a display. She is an artist, and as my first report came out with regard to the World Trade Center destruction and the anomalies and my questions about the official story, Jeanette read that report and she contacted me and said that she had this sample of the dust, would I'd like to look at it. And of course I said I would. I actually traveled to California to visit Jeanette McKinley, and with other scientists present I collected a sample of the World Trade Center dust. Subsequently, dust samples from Jeanette McKinley were sent directly to Dr. Ferrer and to Kevin Ryan. And all of us have seen these red-gray chips in this World Trade Center dust. So the chain of custody is clean, and the science is very sound, I believe, and has been published and not refuted. So we feel we're on very solid ground with these studies. I don't know that I need to repeat what Dr. Ferrer has described very adequately and very well. So I would like to emphasize certain conclusions that we determined from our study of the World Trade Center dust and this red material that Dr. Ferrer has discussed so very adequately. I would like to say before proceeding that Dr. Ferrer was a key in analyzing this red-gray material, and his expertise with both the scanning electron microscope and the transmission electron microscope proved to be invaluable in this study. Okay, so significant conclusions regarding this red-gray material that we found in the dust. The primary elements in the red material are aluminum, iron oxide, as well as silicon and carbon. I'd like to say that the silicon first confused me when I saw that in this red material, because it's not needed in thermite. In thermite, all you need is fuel, aluminum, and an oxide, a metal oxide such as iron oxide, so that the oxygen goes from the iron oxide to the aluminum with the release of enormous amount of energy. And this also results in a production of molten iron. Now, and some of that would be, as you have this molten iron being formed explosively, will form droplets in the air. We do see many iron-rich droplets, both in the World Trade Center dust and in the residue, the ash from burning these red-gray chips. The question about the silicon, why is that present? I think it was Kevin Ryan that pointed out to me that as nanothermite is being made, this is now thermite with very tiny constituents of iron oxide and aluminum. So when nanothermite is being made, typically silicon is involved in the mix. It becomes part of the matrix when the sol gel method is used, for example, which is described in detail in the literature from the defense laboratories such as Livermore. It's a these guys at the defense laboratories are very excited about nanothermite because of its applications for explosives and so on. They do say that all the applications they will not go into. I remember at least one of the National Lab papers discussing the fact that nanothermite can be used for demolition, controlled demolition. So I thought that was interesting, at least for igniting the standard explosives such as CH4. The iron oxide appears in faceted grains, approximately 100 nanometers across, as Dr. Ferrer described. The aluminum appears in thin platelets about 40 nanometers thick. It is the small size of the particles involved in this material that allow us to characterize it as nanothermite. In ordinary thermite, the particle size is much larger, and hence ordinary thermite is an incendiary. Whereas as the particle size becomes smaller and smaller, it can become explosive. Super thermite is sometimes called. Dr. Ferrer found that the iron and oxygen are in a phase consistent, that is Fe2O3. Dr. Ferrer conducted studies in the differential scanning calorimeter and found that the material ignites, reacts vigorously at a temperature of approximately 430 centigrade, consistent in each sample. This is approximately the temperature at which nanothermite ignited in a study published by Lawrence Livermore National Laboratory. Also, the narrowness of the heat trace, the DSC trace, indicates that a very rapid reaction has occurred, both in the study with known nanothermite and in the study of the red material as found in the World Trade Center dust. We found that the spheroids that are rich in iron produced by the DSC test, that is, by the ignition of the red material in the DSC, these have a signature of that is rich in iron with not enough oxygen to make even FeO. So that indicates to us that the iron has been reduced, which again is a signature for the thermite reaction. So the formation of the spheres, which implies a very high temperature, over 1400 centigrade, and the reduction of the iron oxide to an iron-rich phase indicates that a thermitic reaction has occurred. And therefore, we are able to call this a material an active thermitic material, both from our DSC studies and from the results from the electron microscopes. Let's not forget that this red material contains also a significant amount of carbon. And the formulation of nanothermite as described by National Laboratory publications also implies the presence of carbon, very typically. The organic is used with nanothermite in order to produce gas, that is a very high pressure gas that makes the nanothermite an explosive. And so all these results are consistent with the presence of a pyrotechnic or explosive in the World Trade Center dust in large quantities that really should not be present in an office building in downtown New York City. Okay, so we need some investigation that will take the blinders off and say, we're not just going to look at fires. We will consider the possibility of explosives, and we will look for explosive residues, as we have done on our own initiative in the World Trade Center dust. And on the steel that Dr. Farrer mentioned, we need an investigation that will have the power to subpoena these samples collected by Professor Barnett, and then we'll look at the residues that you can see in photographs of this Swiss cheese steel from the World Trade Center 7 and from the towers, and be able to determine if this residue has aluminum entrained in it, as we expect from the use of thermite. This is the residue on the surface now, this grayish residue that you can see. I predict that aluminum will be found entrained in that residue on the surface. Or some other, well, that's, I mean, thermite can be made from other combinations, but one would expect aluminum as the most readily available fuel for this type of a high energy reaction that would result in the sulfidation and even evaporation of steel, because the temperatures can be reached by thermite. In conclusion, I strongly support an investigation, a thorough and fully funded investigation of the events and people involved in 9/11. Allow people to come forward and testify of what they have heard about 9/11 from various sources. We need this investigation. Right now there is, in effect, a dark cloud hanging over America because of these unanswered questions. It would be better to face this head on and allow a thorough investigation and perform this investigation in such a way as to get at some answers. And so we need this investigation, and I think that's all I have to say about that today.